My name is Ivo. I'm a management consultant, and as such I feel slightly intimidated to talk to real scientists. But what makes things a bit worse is that in fact in most of the thing I did, I was helping organizations become more efficient. So I'm in a better position to talk about efficiency, and yet I'm here to praise inefficiency. It is there, probably have guessed, to remind of Ashby's law of requisite variety, and indeed I'll be giving different examples, but I'll use that as a sort of a framework to get everything on the same explanatory base. And talking about efficiency, what I find as the main drivers for efficiency, it's the resource limit and competition. But apart from that, recently the crisis made slogans such as go lean, reduce waste, cut costs, get rid of non-value activities, do more with less, and such like, become really loud. And that's fine, that's good, in fact. But there are also some dangers. And what I'm here to argue about is that some inefficiency is not just good to have. In fact, it is or could be a prerequisite for survival. And I'll give some examples from different areas of living systems, social systems, and then I'll move to a more conceptual setting to try to talk about it and open up discussion, hopefully. And what I will start with is the adaptive immune system as an example. Very quickly, a reminder, what we have there as bad guys, pathogens, and a few good guys, like the B cells, the T cells, the natural killer cells. Although natural killer cells actually would destroy the pathogens, the interesting role is, from the cognitive perspective, is the B cells that recognize and mark for destruction. That's a B cell, and what it has is the surface with molecules which are protein chains with Y shape, which tend to detach and flow with the blood. And then, when they reach another cell called the pathogen, they can just try to stick to them. And the better the shape match, then the better chance that this pathogen will be marked for destruction. Now, there are two main challenges. One is that these receptors that the B cells produce, they have to recognize distinguish dangerous cells, the so-called problem self non-self, which I don't like to call it like that because it goes to a different explanatory path. But anyway, that's the first problem. And the second is they have to deal with uncertainty. They have no idea who will invade the body. So in terms of diversity, they increase the chance that they have this match. If the match is good, what they do is they go to the lymph nodes to reproduce. The better the match, the more offspring. The more offspring, then the more chance to have even better match, and then more offspring. So there is a self-reinforcing loop, and that's how also they deal with the quantity issue. And then, of course, enormous amount of them just don't fit and they die. So this is a huge waste, but it's the best way to deal with uncertainty. And that was an example related to diversity. What I would like to pay more attention to is two other phenomena, which are basically shift of function. One is degeneracy, when certain components that they have some function for some time, they can do something else and then go back. So temporary shift of function. When this shift is a trait, evolutionary trait, then it's called exaptation. With degeneracy, it's in the genetics, in the metabolism, in other, and I'll come back to this later, but now I'd like to talk more about exaptation. I think you have a seminar about exaptation, so not too much, just to remind you that classical example is feathers. They initially appeared as something for temperature control. They trap the air, so they hit the body, and then they open up to cool it down. Later for sexual display, and later for flight control. And there are many examples like that. There are fish that have the bladder that is used for buoyancy control, and people, of course, use this also to describe different things coming from the world of technology, like the microwave invention and other things related to serendipity or unexpected inventions, unexpected adaptations. But the interesting thing is, if exaptation is really something which is quite popular as an evolutionary mechanism, can we make it so that we see it with reproducing certain things in an artificial setting? That's why the next example will be from the world of genetic algorithms. And very simply, these are computer programs. Probably know that, again, using the variety with diversity and quantity, the diversity is achieved by the combination of sexual recombination plus mutation, and the quantity of the parents' offspring. And this is an example borrowed from the work of Mitchell. That's a very simple robot that lives in a grid of 10 by 10 cells, and it has the goal to collect empty coffee cups, in this case. It is a very stupid robot. It doesn't have any memory. So what the robot can know is the content of its own cell and adjacent cells, which could be empty, could be with a coffee cup, or could be a wall. So we have this situation as an input. As an output, can move randomly or to any direction, or could try to pick up a cup, or could do nothing, of course. So with their input variety of 243, we would get an output of, well, that's a huge number. So it's not possible to find an optimum, but we can find a good enough strategy. And this is how actually the parents appear. They appear as rules, what kind of input, what kind of output will produce, and then there is a way to count the result. And depending on the result, if it is successful, like picking up cups, or if there are rewards, and the rewards bring more offspring, and then the opposite would get getting this trait out. So if we have these strings of strategies, then they will give an offspring which will be a combination of them from two parents plus some mutation. And again, defeat the parents to more the offspring. What is interesting, that in a certain number of generations, I don't remember how many, you can simulate it yourself, 1 or 150, at the beginning, most of the strategies are much not so smart as if a human would devise them. But then they become better and better, and at a certain point they really come to something very clever. And it appears that at some point we also see in this setting exaptation. Here is the example. We have the robot at this position, and a strategy devised by a human would probably say, well, if there is something below, go south, and then pick it up, go west, and then around there will be nothing. It'll probably be, the next will be just go random to increase the chance. But the evolutionary algorithm picked up a trait which was different. Go south and don't pick up, because there are gaps in the adjacent cells. Go to another direction. In this case, go south, go east or west. And if there is no more in that direction, then go back. So in fact, what a trait that was picked up was to use the coffee gaps as external memory, as breadcrumbs. And that was much more successful case, and another case for acceptation. But in fact, if you think about it, the local strategy to be there, have a cup, and not pick it up is entirely inefficient. And overall, it's a much more successful strategy. And then the next example comes from the world of ants. I think it's a really exploited world with a lot of work on it, especially Deborah Gordon did a great job. But of course, we can look at certain things from there and try to have insights. I wouldn't recommend going too far with analogies because humans are not ants. Anyway, the good thing about ants is that they have very, very simple behavior as agents. And that's the good thing about it, that we can simulate it. So what I would like to show to you is how they forage for food. What they do is first they move randomly. And that is changed in the following cases. If they meet a food source, they tend to take a piece of food and bring it back to the nest. And doing that, they leave a pheromone trail. If another ant goes to this pheromone trail, it tends to follow it. So that are the only two things that will change their random behavior. Find a food, or find a trace, and then follow it. Let's see what happens. So we have here the nest and 2-3 piles of food. We have two variables which are related to the pheromones. One is the diffusion rate and the other is the evaporation rate. We are not going to touch the diffusion rate. It would give different results, and it's another discussion. We'll play only with the evaporation rate. So the pheromones, they evaporate. And let's see how much time the ants need without changing the number or anything else from the behavior, just by changing the evaporation rate. So first we start with a rate of, let's say, 9, and we count the number of steps. Okay, so with evaporation rate of 29, all food is finished in 997. Then let's try evaporation rate of 8. See now that the trace is different. These are how the 3 hours finish. Okay, so now with 8, we, as expected, finish much faster for 587 ticks. And now it would be interesting to see what happens if we have no evaporation at all. Of course, it's better to have several runs because they give different results and you have to find average, but I hope you can see it even now. We have 686. Why do you think is that? Why do you think when we have a zero, we need more time? In fact, thermal plate doesn't evaporate at all. So
because certain piles are already empty and ants are going there anyway.
Yeah, that's really what's happening. Yeah. Well, in fact, when they follow this trade and it doesn't evaporate, they stop exploring new food sources. They are too much attracted by these pheromone trails and they stop exploring. That's why we have big time when we have a big evaporation rate and then it gets better, but when it's zero, it goes up again. And that's quite an interesting balance between exploration and exploitation, which you can see in many situations. When they exploit too much, they explore less, and when they explore less overall, they have much less discovery and they need much more time to, in fact, and if I have another food source, that will get even worse in terms of the minimized and the zero evaporation rate. But with the exploration and exploitation, it's even more interesting because you can see that as a fractal. So we have if you move it to another setting, that would be the singularization and exploration that would be probably research, and the application of that research would be to exploit. But then, if you go one level down in the recursion, we can have also exploration of exploration and exploitation of exploration. In cases of research, that would probably be, exploration would be a curiosity-driven research, and exploitation would be market-driven research. And again, as started with the effect of the crisis, what we have is the market-driven research is now really with a lot of attention and a lot of support from government as well. We have this top-down policies where the effort is put on the frameworks program, on coordination, on public-private partnerships to have all this idea of the efficiency of research, to work on something which is driven by market forces. And at the same time, that gives much less attention to the curiosity of research. While in fact, if we just look historically, a lot of big inventions like the monoclonal antibodies, they were a result of, in the 70s, curiosity-driven research, and now they're a multi-billion industry. Of course, this policy, which is now happening, has its reaction, and this is a reaction coming from the big research universities, that this suffocating of the curiosity-driven research and is increasing the chance to actually develop new things and survive. The other example comes from play. It is interesting area of research, and I think it started in the 50s from Piaget and Vygotsky. There are a lot of things that happen during the play, especially when you pretend, when you enact something. What is interesting is that there is certain fun zone. In this fun zone, the children play, they play doctors, they behave a certain way. They behave in a way that is ruled by the rules invented by themselves. But at a certain point, this game becomes boring. When it becomes boring, they tend to invent new rules. At a certain point, they stop inventing new rules, they just learn them and they strictly follow them. They exploit them to the extent that they exhaust their fun capacity and they again start inventing new rules. So, in a way, their behavior is quite inefficient because they learn new rules which are transient. They will go away quite quickly. And yet, that behavior is very effective. That's the way they learn new motor skills, for example. Going to another area, we can look at startups in a similar way. There are many startups, but only a few of them are successful. So you can look at this as a way to explore new things, and only those that actually can bring results the exploitation. And going one level down, what was discovered by these guys below, that most of them had a certain initial class when they made a startup, but in fact, 2/3 changed them. So you can see the recursion of exploitation and exploration in this example. Of course, I can't help thinking of the startups as B cells as well, seeing these invariant properties. The other example comes from the potato farmers in Peru, which do something quite inefficient. What they do is they have these long strips of land that could be up to 15, and they're spread around on different hills. So they do not amalgamate and have them as one plot, but they have them just spread around. What they achieve with that is they give up their rights for good yield when the weather is good, just to have something each year. So, in fact, if you see their oscillation of weather, they try to dump it with the fact that in some areas they'll have better weather than in the others that will compensate, and they will not starve in any case. So they sort of make this dumping by this inefficiency. And that sort of thing is now appearing in different areas. But I will bring one example from the work of optimization of application systems in big organizations, which is the following case. I had a client, big organizations with a huge amount of applications and a lot of spendings on IT. And what they discovered is that over 50% are with duplicated functionalities. So they wanted to reduce that spending, but first to find out what is the redundancy and how to get rid of it. So what I did is to propose certain methodology which was doing structural analysis, and I'm not going into details now, but I can explain later if you're interested. To come up with 3 patterns. One is redundancy, the other is underutilization, and the other is new requirements. There was a lot of excitement about it, which had to cool down, explaining that at this level of maturity, maybe there is a high risk that all these projects will fail. But in fact, if they succeed, that's even worse. It's even worse because these are local optimizations, and if they don't touch the procurement and IT governance, they will continue to produce inefficiency. In fact, all these will go to a new equilibrium. something which I would call pathological autobasis. And what will happen is that whatever is currently the procurement process will continue to produce this because it will not be changed at all, this mess. But then if there are new techniques that are successful to discover duplications, of course they'll be supported. And they will be financed if they're successful. But this finance will again increase the EIT budget. And then, if they come up with certain results, that will bring a blueprint to clear the mess, which, if successful, as convincing, there will be money to clear the mess. And then, if the results are good, there will be more money to discover, but that will not change the fact that the mechanisms that produce the duplication. Let's imagine that this big picture is understood. There are not local but global measures to, in fact, deal with it. So somehow this problem is solved. At the end, what normally appears in these cases as duplications are found. So there should be some criteria devised and choose what to remain, and then standardize, something that is often called reference architecture. But then other problem appear, and that is the problem related to the requisite inefficiency. And I will try to explain that using the viable system model. So if you're not familiar with it, I'll very quickly explain what it's about. It's the model by Stafford Beer, but in fact I'm using a different rendition, which I think solves a few problems. Very quickly, the organizations are looked at as several systems that are autonomous, which are called operations, that the system is one. And then there is another system which is dealing with coherency, which is system 3, the meta system, which has several roles, the negotiation of resources, through another system called system 2. It deals with dumping oscillation. This is often called as coordination. And the other system, which is 3, is absorbing the remaining variety by the means of sporadic audit. This is the system which is focused on here and now, and there is one more called system 4, which is focusing on the future and on the way environment is developing. And the system 5 is the one that is making the operational closure and is responsible for identity and the policy of the whole. And this E is for the environment. So in that case, with the IT rationalization, what appears is something which looks like work over system 2, because these are standards, and these standards reduce the freedom of different operations to choose how to address their problems with new IT system developed or bought. But then there is a hidden problem behind, which is that the central system 4, which is looking for the future, it's doing the planning function, in fact has much less information to understand the local uncertainties. And there is a conflict between that system and those lower system 4 at the lower level of recursion that are doing that for the autonomous operations, which would serve very well those operations, those units that work in a controlled environment, but those that work in a certain environment, they have to deal with more constraints. Not only that coming from the change of the environment, but that's coming internally following certain rules. And there having requisite inefficiency would be much more helpful. To try to explain this in a different way, let's do something something simple. Just close your eyes and try to meet your index fingers in front of you. And now please repeat the same thing with your eyes open. Using the same thing, you experience that, using the same thing, when you have imagine you have two operations, two subdivisions at the autonomous, your hands. To achieve this coordination, when you close your eyes, you use, in this case, this system 2, internal coordination. And then, when you open your eyes, and eyes would be something related to system 4, with the visual cortex and everything, then you use system 4 for coordination, not only system 2. In that case, the coordination loop used also the environment. If you don't believe me, try to do the same thing in a dark room. So now forget about this and imagine that coordination is certain function, certain capability, or certain service, certain application service. What you discover doing such analysis is that you have coordination, dependency. So we should choose one of them and standardize. Everybody that makes this from now on should do it like that. And you saw that the better coordination is done through that loop that goes through your eyes and environment, not the internal one in that case. And imagine the other one is cut out for efficiency. So you have only this through your eyes, and it will be absolutely great, it will work perfectly as long as there is light. To review all this in a more conceptual way, I'll propose to use this model of Max Poisson called HB space, where we have the variety of stimuli and the variety of responses, and the actual line of requisite variety is 45 degrees line. And then we have the adaptive frontier, which in case of people could be extended because we have technology, we have other ways to extend our variety. What is in fact happening in general is that if we have stimulus that appears with a certain variety, we are faced with two risks, because we need to have our variety equal so that we can deal with it. But the first one is reducing the variety of the stimulus has the risk of oversimplification. Increasing our variety has limits because we can deplete our resources. So here we also introduce the idea of the cost of variety. But what is missing in this two-dimensional space is notion of time. The other thing which I'd like to review in this case is what is the role of luck and what is the role of uncertainty. Let's first deal with time. So in the same space, if we add time, and we have in a moment t1, s1 as stimulus with a certain variety, and at this point of time, we have low variety, in this case is R1. To get in control, let's have the good case where we can both increase our variety and reduce the variety of the stimulus to get to this requisite variety situation. And in this case, it's possible we achieve it in time. But then there is another one which is with much higher variety, and in that case, we might just not have the time. Our resources could deplete sooner that we can reach the variety level that we need. In that case, if we have additional resource, then this path could be much shorter, and the chance to get it will be much higher. Or if you look at the cost of variety, this function could be presented in different ways. Quite often it's presented as this exponential one, but I would rather believe it's more stepwise. Anyway, in both cases we have this point where we have the requisite variety, and we can say that if we have more variety, which we don't need, that would be a waste. This is something that we can reduce. But in fact, if we put the notion of time, these two dots, they are the same, because we need this variety gain in time, and will be there if we have this additional capacity. So we can have this, the following situation when it comes to that additional resource. It could be essential. It could look essential, but it's not serving the purpose, so it has no other value, then it's really. Or it could be a waste, and the other situation is that it looks waste, but it's needed for adaptability, which is the case of the requisite inefficiency. That was the time, and now let's look at the work. So let's imagine that we are at position A, and we need to reach position B, but at position A, we don't know on which path we will have the requisite variety. And to do that, we need to invest. We need to go to one of these dots, and then, only then, we will know. And this will be the one that is the winning strategy. So if we plot that, the most lucky, let's say the cost to get to this point is 1 million. The most lucky will have the requisite variety for 1 million euro, and the least lucky will get it for 7. So the actual spending to get this variety will be quite different. When looking at that, I thought, could it be that also Ross Busby, when developing his homeostat, it was something that for the first time showed adaptive behavior. And if adaptive behavior always has this requisite inefficiency, maybe he also saw it somehow. And to be honest, when I first read the design for a bread, I couldn't find it. And luckily, in the second read, I just read this, that the homeostat performance is something of inefficiency. Because the second loop, which is looking at the extension parameters of the first loop, is when they go out of these ranges, of their ranges, through a random step function, it tries to find new configuration when there could be back to the normal ranges of viability. So it was there already, and that was also the case where there was a way to deal with uncertainty. Then later, Olin introduced also in the same equation for the control for the requisite variety the idea of conditional entropy. To what extent the regulator knows what is coming disturbance, and that could be another way to look at the uncertainty. Of course, having more ignorance about it, one way to balance it is to having an additional variety that is more than the seemingly requisite one. But there we fall in an interesting trap, which we also see in the crisis. The more uncertainty we have, it drives us to have more efficiency measures. that would, of course, reduce inefficiency. But reducing inefficiency as a whole, that would also reduce that part, which is the requisite inefficiency. So, in fact, if we look at what we have to get rid of as a pile of waste, ideally we can imagine that we get the bad part and then we reach a layer of the good part and we stop. But that's not the case. You can have this from the beginning. And here is the conflict that the more uncertainty, the higher level of requisite inefficiency we need. At the same time, we have more efforts to reduce inefficiency and no special efforts to see which of that is good, which of that is bad. So that was an overview of that, including redundancy acceptation. I didn't talk much about serendipity. Now, before going to the discussion, there's a question that I'm always afraid of, so I'll ask it myself. The question is, so what? Three things which I would like to share some conclusions. It's better, if that was convincing at all, it's better to know about it when implementing efficiency measures. And it is not only about being conscious not to eliminate it. In some cases, it can be ensured by design. Two popular cases. One is, you would call it, using biological terms, degeneracy. The way army, which has a certain function, is used in situations of floods and earthquakes. That's happening quite often. But what would mean to design? To design would mean to have special training programs, because it's quite important to be able to successfully shift that function in these cases. And recently this appears also with ambulance. In some countries, there are initiatives where certain taxi cabs and fire trucks are equipped, in some cases, to work as ambulance. For taxi cabs, that's very, very effective because they know very well where are the things and they have a good way to be there and they have a good network. So it's already happening, but it could happen to a much better way. It seems that from the examples that I showed, there are more. It's more during exploration, adaptation, and innovation. Or if you look at this very simple model of operational enclosed system, which I think is what living systems and social systems share. One simple way to look at them is that they have three sets of loops. One is the identity loop, or the loop of operational closure, the loop of autopoiesis. The other is the sensory motor loop, which out here would call experience, and the adaptation. And recognizing where something is, in which kind of loop, it is it seems to me that what I've been talking about is almost always when in the adaptation loop, and almost always in the experience loop when it is in an exploratory mode. And that was all so far. Thank you. Now is the time for questions.
Thank you. Well, one general comment is that inefficiency is defined negatively. It says it's not efficient, but it doesn't say what it is. You gave us several positive examples: exploration, diversity, redundancy. Then the question is, shouldn't we just call it these specific things? We need redundancy, we need exploration, we need diversity, rather than to say we need inefficiency. Inefficiency is in a sense only a side effect of these positive measures. It's not that we are looking specifically for inefficiency. It's that we are looking for other things like robustness, and so on that have inefficiency as a side effect, but we're not really looking for inefficiency.
Yeah. That was more or less a reaction towards a lot of crude efforts for efficiency, just to show that what is understood as inefficient, it could not always be inefficient. Sometimes it's something that should be looked more carefully. Maybe at this point it looks as non-added value. Maybe at this point it looks as something that we should get rid of. But it could be that this is a capacity or flexibility that in a new situation which cannot anticipate now can be their survival factor. So the choice to call it inefficiency is just a reaction to very crude efficiency measures. That they just blindly go and wipe everything. But I fully agree, of course, you can look positively that unfortunately a lot of money is spent to cut things without really looking carefully at what is the function they have, and is this cutting done just by the current look at the situation, expecting that this situation will remain the same, which is more.
Yeah, I would maybe compare the use of the term inefficiency to the use of the term inside of non-linearity. Non-linearity is again one of those negative terms. It doesn't say what it is, but because everything used to be considered as linear, it's not bad to emphasize it, like we should not stick to the old paradigm of always assuming linearity. So also look at the non-linearity. But at a certain moment you come to the stage where you can say, well, by non-linearity we mean particularly this, and then you can be more explicit. But in the first stage it was useful to call it non-linearity just to remind people the world is not linear. So by assuming linearity you are restricting yourself, just like saying the world is not based on maximum efficiency. By restricting yourself to looking for efficiency, you are hurting yourself.
Yeah, exactly.
I think if you can go back to one of the last slides about the three loops of operationally closed systems. Yes, I think here, when you look at systems like this, you see that there is almost an inherent bias towards what we know. A system, when it gains knowledge, any kind of knowledge will be biased to continue its processing based on what it knows, and this is, and there is no balance between what the system knows or what the system doesn't know. And I think that everything that comes from any relation towards the unknown can be considered as a kind of inefficiency. And this is a very deep bias. When we gain some experience about the environment, we will base our future actions, designs, etc. based on this knowledge, because there is nothing we can do about what we don't know. But actually, these two aspects of the reality of systems, actually there is always more unknown than known. So it makes a lot of sense to be prepared to the unknown and not only to what we know. But that's quite difficult.
There is not a bias there, because being prepared of the unknown means being prepared for what you consider as an unknown range, more or less. So you have either idea about the future or the things you don't know, or you have historical data which you want to extrapolate, or in fact something is there as a resource that you can use in unexpected situation, which likely could be the one that you could use semi-developed and currently in use resource to change its function and meet this new situation, and you can have the needed number of states to handle it. Or you may fail, you may not have a choice. But to have something that was not used but has certain structure and that could be easily changed to fit this could be more possible in the time that you have for adapt than to start and from scratch develop this new whatever organ function structure. It's the same picture with a bit more things in it.
This is rather conceptual elaboration that you presented here. What about some methodological points? Is there anything in methodology in a specific cases would give a guidance how to react, what to lose, what to leave, what to abolish, what to change? I mean, it would be good to have a practical, guidelines out of conceptual development.
To my understanding, that goes a bit contrary to the idea itself, because giving guidance, giving recipe would be as if it is known how to go about it. And this recipe might stiffen certain things that are inflexible to react in a different way. I would rather consider from one side having awareness about it, knowing more about the power of serendipity, knowing more what exaltation is, and when it's possible, like I said, in the case of degeneracy, design systems that you know can successfully shift functions in the case of unpredicted disastrous events like floods and earthquakes. Or, alternatively, maybe there is, but I don't know yet about it. Still, maybe together we can find something. But this would be based on certain preference of some patterns, on certain hypothesis bias, which will bring this recipe, this guidance, and it would have a range of applicability, and something else happens, it would not. We don't know what will accept. We don't know what will happen. That certain things which we would be more economical if we don't have, having them would help us do something. But at the same time, having them too much may deplete our resources, they may not get there at all. So don't get that as a message to be inefficient at all. That's not even close.
Okay, actually, you gave a little bit of a guidance to this, what you said, awareness building and giving with that, because I didn't ask actually, my question was not ask for recipe, obviously, because recipes can only work in a certain very, very stable, very known environments. But if your environment is changing, you need to adapt to it, the system needs to adapt to it. Obviously, only a kind of a framework could be envisaged as a help, not a recipe.
Certain lenses, like for example, having this idea of the balance between exploration and exploitation. Now we see this in practice everywhere. Before, people develop software in the following way. There is some exploratory phase, discover the requirements, then there is some fixing of specification, which is more or less exploitation, and then writing the system, and then commissioning it. And then the actual exploitation from the user starts. And that's it. So, in fact, the user in a year is using something with the knowledge from the previous period in new circumstances, and they know more about themselves. So, when they do something, this loop brings them new awareness. And now this thing is changing. now releasing the software is not so much exploitation than exploration. You bring some new features to see how people will react, and then you change, and people release in small cycle. The granularity is changing just because the uncertainty is bigger, and people try to get this balance right. But that could be one, let's say, guidance, understanding this balance between exploration and exploitation, which is in many situations.
So there is also this principle of anti-fragility of Nassim Taleb.
Yeah.
Is, create a lot of experiments and just make a system in such a manner that failures are kept local and success is being widely distributed. So you need only one success in order to cover many times over all the small failures that you have had. So it's a kind of balancing the cost function, creating a lot of variety, but failure cost. But you, in this variety, you limit the cost of failure. But even single success is very profitable. So
yes, indeed, with one small remark. If you have certain series of shocks which make something stronger, make something anti-fragile, but they have certain type because of whatever, and then in a different era you have totally different type of unexpected events. It might be that anti-fragility is something which is an optimum, but local optimum. And it might be useful for, let's say, unexpected events in a certain range, in a certain direction, and then totally different type of unexpected events can make that anti-fragility useless. I'm not sure that it's universal enough to apply.
In principle, anti-fragility, that whatever event there is, it would rather strengthen and weaken the system. But of course, you never know. You never know until the perturbing event happens whether you are anti-fragile or fragile towards it. It's maybe another variable I thought is the difference between specialism and generalism. The more specialized something is, the more efficient it is, but the less likely it is to adapt to something else if things change. A more generalist will be less efficient on a particular task, but will be able to shift more easily to a different task.
Yeah, but how do you deal with the trap? That's of course the case. But how do you deal with the trap when you shift to a different task and then you meet a predator that is already specialized in that task? Because you don't have the time being with the general level to gain the variety, to gain the experience that you need to deal with that. I'm just not sure. That's
No, but in a company, you would think that you need a number of specialists, but you should also make sure that there are enough generalists. Generalists may not be as efficient at any given moment, but the moment something changes and the specialists don't know what to do, then the generalists will step in.
But in such a case, in a company, you simply have your own resources, even a generalist and specialist. I mean, I would rather say you need generalists that know your system, whatever it is, and you can hire and buy your specialists. That's quite normal in the business world. I would say, but I have actually some other question that reminds me of what you presented a time scale in this requisite variety. I think this is actually a good example to think of at the time, because resources are normally bound in time. We don't see that, but you know, you have the annual budget, or you have the annual 5-year annual budget. You know very probably, and you know you have some idea how much would you spend. So a big, or let's say a short timeline and a big change, it's contradictory. But if you do it gradually, So, as you've shown, a small step in time, a small step in efficiency or whatever it is, would probably stabilize the system on the long term. Might not be optimal, but it will assure the progress. It will assure the line that you picture here. Between the, let us say, requisite or inefficiency and time and whole life of the system.
This thing with generalists and specialists division, I'm not sure it's always applicable, but it seems that the specialization was a quite successful thing in the Industrial Revolution and later until probably the 70s and 80s, because the level of change was different. You could quite well know many things in the next 5 years. It's no longer the case. And maybe that was the reason that now people review the whole history of science and they see the reductions in that. Because they bring these tools that we need now to deal with uncertainty. And people talk more about either generalists, talk more about things like agility and anti-fragility.
One problem I have in general with the law of requisite variety is that it's very difficult to measure the actual variety of what your stimulus in your response. You can't really, in Ashby's scheme, you have a set of all the possible stimuli and a set of all the possible responses, and then you can take the logarithm of that to calculate the variety. You don't know what the set is in reality. Are two different things, are they the same elements, or are they different enough that we would use them as different situations? And even then, you see all the variety that has been there over a certain period, you don't know what the variety will be the next period. So in that sense, the law of requisite variety is good to remind us that we need variety, but as an actual measure, it's very difficult to apply.
I fully agree.
You must make assumptions about the system, about the signals, the ranges of signals in order to make it. So it is based on a model that you have to create out of nothing. Yes, it's not. You can observe the environment, but you cannot capture everything there. So it's
I always interpret it in terms of the environment as a potentially infinite variety, because it can always produce something that you didn't expect. So, since you cannot have an infinite variety of response, try to have an as big as possible variety of response. Of course, as you say, you don't always have the resources to make this big enough, this as big as possible variety, but as big as possible within your range of resources.
There is this world of relevance. The relevance is always related to the system which is measuring. It's not related really to the environment. It's always a kind of a filter that.
It's a relative thing. If you don't have the system, you don't have the world of relevance. That's the niche that is produced only by the system interacting with the environment. So it's the local world of meaning that is surrounding the system. I fully agree that it is not useful if you think of it as counting, but it can give other insight to understand if something is there or not. As Stafford Beer said, when you see the wall, you don't count the bricks. If they're enough to reach the ceiling, you just see that the ceiling is fine. It goes to the top. So the good and bad thing about variety is that it is something which can absorb itself various dimensions. It could be something related to quantity, could be quality, could be time, could be some gradient, different things depending on the situation. But the beauty is that it's only one variable that can somehow apply to more as a way of looking at things than as actual thing to count and measure. But I still find it useful, and in some cases even try to compare if you use that approach to understand something or something more contemporary, like dynamical system theory. That they have the similar thing, but they don't call what they call about state space. They call it attractors and other things. And although they're serious achievements, I still find that old, maybe simplistic way of measuring complexity quite useful. With all the understanding of it.
One maybe more difficult question. You mentioned the Owling version of the law of requisite variety, where there is also the conditional variety. But you seem to imply that if there is too much conditional variety, meaning too much uncertainty about what you should do, you can compensate it by adding more variety. If you look at the formula, that seems to be the case, but in the reality, I don't see how it would work if you have more variety of responses and you have great uncertainty about what response to do. Increasing your number of responses, I don't see how that helps solve your uncertainty.
Well, that was, for example, like the case with the immune system. With the big number of the diversity that it can generate, the B cells in the bone marrow by having this enormous mutation rate, then it doesn't mean that this increase would guarantee anything, it would just increase the probability. That's all.
Yeah, but
it wouldn't balance. It would increase the chance to have a balance.
Yeah, you mean if you try them out, if you try out all of the possibilities, you have more chance that one of them will be successful if you have a lot than if you have.
First,
yeah, that's the basic principle.
Well, first if you have the time, and then
if you have the time to try them out all, or if you have the number to try them out all, which happens in the immune system because we normally have lots of pathogens and lots of antibodies available, so you have plenty of occasion to try them all out. But if you are a person or a company that has to decide, are we going to take this action or that action to counter this perturbation, you usually can't try out 1,000 actions at once. You have to try out one by one, and by the time you find the right one, it may be too late.
Yes, but also we have a history of successful adaptations. So it might be that the new disturbances, some of them have certain patterns where you can quicker go to the previous case where you had the successful adaptation, which was also used in the idea of the next system developed after the homeostat. So when you adapt successfully at certain situation, then the situation changes, you adapt again, let's say, and then again, and then there's a new situation which is quite close with the one before. So if you have the memory of the previous adaptation, you would not go randomly. You would probably and
but then you need to get outside of the variety framework of Ashby, because in the variety framework, each possibility is a discrete possibility. They are not related. Well, if you work, for example, with a neural network, you can have two different stimuli, but that are similar enough so that the one that you learn how to deal with the one, you can apply to the other one. But in Ashby's approach is pretty unusual in the sense that he works with discrete qualitative variables that are just these distinct possibilities. So you cannot say that two things are similar. That's the disadvantage of the Ashby framework.
He tried a device that had this, but it was not published. There was only one demonstration with it. So maybe he was a bit ahead with that problem, but it wasn't shared. But there was something in relation to that.
Oh yeah, it's interesting.
It was called something like that. Much later, it was presented at the Requisite Club.
your experience with organizations? Do you recognize some of these things?
Yeah, I was thinking about universities, like all this, all this public policy of getting more and more efficient and accountable, and all this World Bank policy starting from 60s that everything has to be applicable and responding to needs of a society is still in this framework of exploitation. Efficiency has to be immediate. And, business world is already in different place. Mostly, IT companies and organizations like that already are all in. It goes like from my perspective, it goes for all sectors. Like, efficient exploitation versus exploration phase development. So I think we started with public domain and public policy at the beginning, and I think it's applying efficiency rules to the world that is already in a different place. That is my observation.
Yeah, I think especially in universities, the good thing about universities is precisely that you have lots of different researchers trying out lots of different things, and if they are then evaluated by simple efficiency measures like the number of publications or the impact factor of publications in the short term or the amount of money they bring in, you will force them to abandon lots of possibly interesting avenues that may lead to breakthroughs, and they will stick to the things that are kind of more or less guaranteed to give you some results, but probably not the really revolutionary results. And I think it's really very counterproductive, this whole emphasis on efficiency in universities.
Well,
Yeah,
that was the comment he made about market-driven and curiosity research.
Yeah.
Market-driven versus curiosity-driven.
Yeah, it's not only market-driven, it's the idea that you should have some kind of a measure of efficiency, like number of publications in Web of Science journals. That's at the moment kind of the most typical efficiency measure. But which assumes that you should have results quickly enough of a kind of type that is sufficiently standardly recognized that you can get it published in these journals.
Yeah, don't try.
But when you start out with something new, you have no guarantee that you will get with results in 5 years that will be publishable in those journals.
Historically, universities seem to be the very places that were all about was exploration, balanced with all the organizations outside universities that were more efficiency. Maybe it's just changing places.
Yeah.
That's sort of the code word in North America is STEM research. But STEM research is code for market-driven research and getting rid of intellectual, curiosity-driven work just simply for research that will have some sort of result for the business world. Even just yesterday, 2 days ago, now there's legislation that was passed where climate scientists now can't even comment on EPA proposals, like Environmental Protection Agency proposals that were influenced by their own research on climate science, just because it will have a negative effect on business efficiency.
So that's limiting the freedom space.
But we're in it right now. This is what's happening. This is the heavy.
This is probably more dangerous than the, let's say, driving universities from the government side, which I estimate as only a measure to improve your efficiency during the time of crisis. And I'm quite sure that maybe in a couple of years it will be realized that there is a non-core, fresh ideas of really this curiosity research. And then obviously you will see that this will be stimulated. It's simple, I would assume, an oscillation in this policy, which is not good. I think the proper balance should be achieved and not pressure on universities, but rather high pressure on to do the transfer of the research, that was basic research, into the business area in order to, to take advantage. So spin-off, things like that should be solved. The efficiency of the research, or as a rather impact of research, to be seen in new technologies created where possible. And all the technologies, some social research, acceptance of technologies.
But it's exactly that. I mean, it's the social research, the human context, just understanding for understanding's sake, just looking into an issue just because, oh, no one's looked into that, but you don't know what it's going to lead to. I mean, that's the research that's, what's the benefit? Well, that you can't get it funded.
But again, the research projects, they compete grants. Somebody has the power to decide on grants. And also dependency from other sources that sustain that power. So these people that make the decisions, how they assess the grants, by which criteria. It would be something which is market-driven, something which is currently involved, or combination of, or something that would actually keep them to have this authority to continue to decide. The whole thing with applications when something is certain gain, and what is the rate of change of this gain corresponds to the rate of change of what is happening outside, including the way peer reviews and everything is.
Much is changed by the form of working, which is project. Projects are themselves very efficient things, efficient increasing the efficiency. Right? So if research starts to be done in the form of projects, it immediately loses all this, qualities you're looking for.
I fully agree. The idea of a project is that you have something with a visible output within a certain number of years, and you have a number of milestones and deliverables, and you have to work towards those milestones within that time. And that means that you have to restrict yourself, and that you can't explore all these other things.
Evaluation of projects is feasibility, if you can do it, what you promise, and things like that. So it's all about cutting all the.
Yeah. I think there should be a funding scheme where people, either on the basis of a kind of a general showing of promise, or when they're later on the basis of a proof that they have achieved things, are given kind of a lump sum, and they can do with it whatever they want. And if they get more and better results, that some can increase. If it turns out that they're no longer so productive, that some can decrease. But they should not be required to tell exactly what they're going to do with that money, because that means that they will not be creative anymore.
I encountered this firsthand in the master's program, where your requirement to get into the program was to write a proposal for what you're going to do in the program, but it was just a song and dance. Like you had to put it in, but they weren't expecting you to do exactly what your proposal said. So if they've already sort of admitted in that sense that it's not the way to do it, like that's not functional at all.
No, it's often just fake. Like
it's
you
fake,
have to
yeah.
claim that you're going to do that thing, but actually, if you do something else, as long as you get the results that you like.
Exactly. I mean, it's an impossible way to do research. You can't.
If anything, questions should be formulated. And if you have a really good question, okay, you can get not what your answer will be, outcome.
Well, I think that stems from a public accountancy. I mean, there's a public money, and you need to know. I think in medieval time it was much better. There was whatever found, I don't know, there were some sense who just for curiosity or for whatever spend the money for a couple of researchers. There were few indeed, and the impact was big.
But it's World Bank put it very recently, maybe in the 60s. It's this new way of looking at public money. It's
Is managing by projects really enough? Because in the pharmaceutical, only, in fact, less than 3% of the projects give any result. But it's enough to compensate the spending for the rest. Well, there are other areas where each project produces something, it has delivery, but the actual value of this delivery cannot be measured during the lifecycle of the project. Some of them just, but they, during their frame, time frame, they are regarded successful because they deliver something.
It's in Poland, for example, where I come from. We had all those structural funds from the European Union, and much of that went to innovation, like increasing innovation, and all projects were successful. So it's impossible, right? But it was unacceptable for a project not to be successful because otherwise the money would have to be returned. So innovation itself, you cannot promise you will deliver. You have to try and see what happens.
Yeah. Well,
if you look where the money went, it went to various innovation agencies, creation innovation agency, just to create the awareness more or less, but, and try to give some kind of let's say platform that the real inventors could work on, a little bit of support. But you cannot you cannot force someone to be. Have it or you don't have it.
And most real innovation is not random, but completely unpredictable. Like some of the best examples are like the most innovative web applications, like Mark Zuckerberg and Facebook, or like the YouTube team. They were just these were just people working in their homes. No one could have foreseen what they would become and so forth.
Probably more of a front end than for a business, except if it's super effective. You may need more trick.
My favorite example was scientific curiosity research. The two favorite examples are Darwin with natural selection. Just pure curiosity. Just going off on the Beagle on the boat, just collecting plants. No, like imagine if he was coming up with a research proposal. Like before he goes on the Beagle, why is this being funded? So, and then
like they 100% unsuccessful.
Exactly. And the second example is Einstein with relativity. I mean, he's not even in a university. He's just thinking in a patent clerk office, like imagining himself on a sunbeam and stuff like this. So I mean, some of the craziest stuff, some of the best stuff, just comes from pure, just curiosity, just pure.
And then what is innovation? In some cases, there is a concrete problem, and different groups are trying to solve it. Like this now, Ebola or something else. And maybe somebody, through some innovation, they come up with something, and it solves it. It's clear that it's innovation. It's clear that imagine something else, like Zuckerberg. You do something, which is nothing, and then you don't know what it is for. And then it creates a new world. You didn't solve anything. It creates a new world. It's innovation again, but a completely different kind.
Can you show this slide with organization? I think it's
Which one?
organization. I think the bottom one with the
The viable system model?
yeah, system 1, system 2, things like that.
Yeah.
I think the one on the left is
On the left.
yeah, probably this one. I think this is an example of hierarchical organization. I suspect.
No.
No.
No,
Was
there is no
system-
here. There is here. It's just unfortunately it's shown only one level of recursion. And here there are more. So it could be any type, completely flat organization. There is no hierarchy. fact, there is no mapping to structures and certain positions. You can say that one person in different behavior is as part of different subsystems. The same person. That's why these boxes are not organizational boxes at all. They don't have mapping. They might have mapping in some situations, but in most of the cases not. They're just subsystems. So, for example, we decide to meet somewhere. The fact that we agree on the place and time is our system too.
Yeah, but as far as I remember, when you talked about that, it was so you have let's say different operations in the organization, but you need to have criteria whether operation is is needed or not for the organization. So something above has to decide of criteria of selection of that variability which is on the level below. How does that happen in the completely flat organization?
Yeah, but you can look the same way at your body. Who decides in your body that you need the liver?
Who decides?
Yeah, the liver is a separate function. Semi-autonomous. Who decides you need the liver? Or at the lower level, you have various types of cells. Who decide that this cell is that is not?
Survival criteria. If I have no liver, I just don't survive.
No hierarchy answer. It might be, but it might be not. I mean, it's a matter of how the regulation is.
I mean, there is some sort of selection criteria which is imposed on these lower level subsystems.
That's why it is called a viability model, because it is related to viability. I mean, whatever is viable, whatever would keep the system to live. It has certain range and could work in that range. And then if it's outside this range, it dies. So these are, if we use the Ashby's terminology, like homostat and a homostat in a recursive way. So each one regulating the other, and some of them, in this case, is system 1, which are immediately interacting with the environment. Imagine somebody serving a client. Or system 4, which interacting with the environment in a way that the environment is changing. Imagine marketing, imagine research. In the same way as you said, you have some function, a core function like the metabolism, and then you have something which can help with the anticipation related to your future viability, for which, for example, you need your eyes to find food or something else, but data. Now, if you have a way, you can just deal with your metabolism, and this will keep you alive in this sense. That's why I used a visual system as something similar to System 4, because its function towards viability is not immediate. You can live without those. You cannot live without metabolism.
If there is no sort of structure of organization, just flat, can you call that organization at all? Does it have an identity as we understand? Okay, organizations can have identities, like human bodies too. But is there identity in this one?
Yeah, I mean, organizations, they how would you call an organization if it doesn't have an identity? I think organizations first have to have an identity, and then if they are autonomous organizations, it is a self-produced identity and self-maintained identity that's specific for them. Now you can use different explanatory framework why this is so, as long as you subscribe to the operational closure. It could be coming from more from biology. It could be coming from, like in the case of women, different understanding of the communications and so on. But in any case, if you subscribe to that, then you can use that model even for a completely flat organization, because different functions, different way of behaving of different people, different tools, different settings, like a meeting, a phone call, they would be part of different subsystems because of their role for the coherence, or because of their role for the autonomy, or because of their role for certain regulation.
I think what I'm getting to is that this what you call operational closure, which is the identity of organization, it becomes a constraint on these lower level subsystems.
Yes, that's
otherwise it won't have an identity.
That's always the case. So in fact, if you see it this way, when you have operational closure, that would mean something which would define the autonomy of the whole towards its environment. So it wants to be autonomous. It has other parts with different functions that they want to be autonomous to serve their function better, but they're constrained by the limitations of its identity. So you have the balance between coherence and autonomy. If you have a team of people and one of them has 10 tasks and can do them in one day, the way he or she wants, but then there is a manager, which because this guy is a part of the team and this team has to work according to some standards, cannot apply the solution it has for some of the tasks because he has to compile the standards. And apart from that, have to produce 2 reports. So in fact, the autonomy is reduced because of the forces of cohesion. But at the same time, the same person being as part of this bigger system can achieve more than alone when could have full autonomy, because it will not have the protection, it will not have the scale, it will not have the synergy effects. And in fact, when several units have their autonomy, what they can do, they can share resources. For that, you need to decrease their autonomy because there should be some way to share these resources that are limited. Then they have to do something, and this something should be coordinated because everybody can do it whatever they want, which would not, they would try to compete. So all these needs that appear when they have to do something together or they share resources require some sort of limitation of their freedom, which here it is called coordination. It's a way to regulate, but it could be produced by them. In some cases, it's produced by something else. It could be produced by we coordinate transport system with some way of solving this scheduling tasks, and you have tools like timetables to do that as well. Then in other cases, you may have a different coordination mechanism, like we agree now that we talk in English. That's part of our system too.
And that, after we agree that we talk in English, that starts to influence ourselves. So there is some sort of downward causation. We create this sort of layer of coordination, which becomes a higher level of organization, and that becomes the system itself. And the system sort of it tries to persist. So it's a kind of autopoietic system, which means it will try to stay to persist no matter what. So it will influence lower levels just in order to exist or to keep its own identity. That may not be efficient. It's the social system as an organism.
But by lower levels, you mean?
Lower level, let's say people which sort of created this social system, whatever coordination system in the beginning.
It's a bit different. I mean, our coordination system is created by our interaction.
Yes.
It doesn't have in itself autonomy. Well, we do have autonomy, so we are quite different. Our drivers are endogenous. That thing exists because of our interaction as something making this interaction beneficial in a way that our interaction is progressing.
So you mean it's very easy, let's say if we see that the control system that we created is not efficient anymore, meaning for us, it should be very easy to create another control system. But I think this is not the case. It's very difficult to create another control system when there is something that already exists. And this is this organizational change and
depends on the value of doing something together. Because you see, here you have autonomy only on this level of system 1 operations and at the overall. And then at the lower level of recursion, again you have that. But that's not always the case. There is no autonomy here. In the coordination, there is no autonomy for the audit. There is no autonomy here as well. They exist because of the needs to keep the whole, to keep the coherence of the whole, to keep the identity. By themselves, that they would not. They would not. They're just in relation to something else. They don't have their own self-produced identity. They have identity, but they're produced by the other subsystems.
You mean it's not self-sustaining?
It's not self-sustaining. It's sustaining because of the others.
Okay.
Well, in some cases, you may take this out of everything, it will survive by its own. Because it has this internally produced autonomy. It has agency, it has directness towards the environment. Of course, maybe the analogies between living in social systems should not be taken too far. Maybe they have some limits. In terms of how the identity is internally created, it's quite impressive how many things are invariant or seem to us when we look at them this way. Let's put the observer in the picture. Initially, that model was developed with the inspiration of the nervous system. So there was a mapping of different parts of the nervous system to this 5, and so you can check it with the first book that appeared in 1972. Then it was abandoned and went to in a different direction. But I find it still relevant.
Which one?
40 years later.
Are you talking about
Stafford Beer, the first books about the variable system operators. Brain of the firm, and then later he abandoned these analogies with the nervous system in the path of enterprise, where things are in different directions with the same principles. And of course, it looks pretty differently. I have a few issues with that model, which I tried to partially solve. So this, what you see here, is very different than the original one. Explaining that.